So this is going to be part 2 to the section 2.2 notes. So far we looked at fractions that had different denominators, and the easiest way to compare them was to find the common denominator. Sometimes the first denominator is the smallest and the easiest one to use. Sometimes though, the first denominator that you get by multiplying the two denominators here is pretty big. And a lot of times there's a smaller one, a least common denominator that you can find by listing the multiples of each denominator and then finding the smallest number that they have in common. So refer to part 1 for looking at two fractions with different decimals. So what I'm going to do here for part 2 is we're going to go ahead and compare a fraction and a decimal. So we're going to look at 1.3 and we're going to compare that to 0.3. So that's kind of rough. That's a fraction, that's a decimal. They don't really have all of that much in common. They're both rational numbers, but they look bizarrely different. So how do we make head of or sense of this? So the easiest way to do this is to convert either this one to a decimal and then compare the two, or this one to a fraction. My preferred method is to convert the decimal to a fraction, because here you would have to do long division. A spoiler, it's going to be a repeating decimal. Those are painful. Converting a decimal into a fraction is usually painless because it's a pretty easy conversion. So when you look at decimals, you look at the number after the decimal. If the first number after the decimal is in the 10th place, the second one is in the hundredths place, the thousandths place, and so on and so on and so on. So here we have just 0.3. This is also known as 3/10. The 3 is in the 10th place. So you can rewrite this as 3 over 10, 3/10. It's the same thing. It's the same fraction. And now, this makes it a little bit easier to compare to its neighbor, 1 over 3. I'm going to bring that guy down. Now they're both fractions. They do have different denominators, that's true, but at least you know what to do there. You find the common denominator. So the CD, or the common denominator, is going to be 3 times 10, which is 30. Now you can look for the least common denominator, but you're not going to find one because 3 really only has one multiple itself, and there's no way that you're ever going to find a 3 in the multiples of 10. So this is going to be your least common denominator as well. So 30 is about as good as it gets. So that's fine. We can work with that. We can work with that. So I'm going to rewrite 1 over 3 here. And how do I get 3 to become 30? I can multiply it by 10, you say. Oh yes, I can. And of course, I do the same thing to the top. And I get 10 times 1, 30 on the bottom. Excellent. So now let's take a look at this guy. 3 over 10. How do I get a 10 to become a 30? But of course, multiply it by 3 and do the same thing to the top to keep the fraction balanced. And that gives us 9 over 30. So difficult to tell which one's bigger here, because first of all, they're decimals and fractions. They have nothing in common. Even when you converted them into fraction, it was still kind of hard to tell which one's bigger, for good reason. Their values are really close, but now that they're in this form, it's real simple. This one's bigger, of course. So the 1/3 is bigger than the 0.3. Let's do another example here. And let's go ahead and compare, let's see here, a 1 over 5, and I want to compare that to a 0.17. So before, you just had one number after the decimal. That was the 10th place. Here, you have two numbers after the decimal. You have a number in the hundredths place. So to rewrite this as a fraction, you're going to write it as such. 17 over 100. Because you now have a number in the hundredths place. You no longer are just confined to the tenths place. I'm going to rewrite this guy down here, 1 over 5. And we're going to go ahead and compare the two. Well, the first thing we need to do is to find a least common denominator. And the easy CD, or the easy to look at, is 5 times 100. And that's 500. That's a big number. So what else can we use as a denominator aside from 500? Because that one is kind of painful. So I'm going to go ahead and rewrite. Or I'm going to find the multiples of both 5 and 10. I'm going to write 5 here. I'm going to start finding the multiples. So I have 10. That's 5 times 2. 5 times 3 is 15. 20. 25. And so on and so on. And eventually you're going to get to 100. If I write the multiples of 100, well, the first one's 100. 100 times 1. Oh, and take a look. They have a least common denominator. 100 itself is the LCD here. So you can use 500, but the 100 is so much smaller. Let's use the 100. So what do? We're going to go ahead and convert both the denominators into 100. Well, the 1 over 5, how do I get a 5 to be 100? Well, I'm going to multiply it by a number. Specifically, what do you say? 20? Yep. Remember top and bottom as well. And that's going to give us 20 over 100. I don't have to do anything to this guy. He's already over 100. So there's no modifications needed. So I'm just going to write it right over here. Which one is bigger? Now it's so easy to see. The 20 over 100 is of course bigger than the 17 over 100. And that's it. That's all you do. So if you have any more questions, just ask during class or see me at lunch or after school. So thank you very much for watching my video. Hopefully you find it useful and have a great day.